So, hi. Today I'm going to present you about my project, which is credit card predictive analysis. And my name is Devi Manasvi, and I'm going to give an introduction regarding the credit card analysis and also the overview and regarding the data set, and most probably I will be explaining the data cleaning and also feature engineering and also exploratory data analysis and data modeling. So coming to the overview, we can we have credit card applications which are frequently sent to banks in a variety of circumstances. Mostly the service providers must first consider their customers' credit histories before determining whether to offer the service or not. So many of the applications are turned down for variety of reasons, like including large loan balances or low income levels or any applicant's credit report which is having too many inquiries. So it is most probably like time consuming and also like prone to error to manually analyze these applications. So in this project I'm going to automate the process of predicting credit card approval, and also I'll be using the machine learning algorithms, though this it like it is like will be understanding which factors affect these target variables are the most. And coming to the data set, I've taken the data set from Kaggle, and there are two data sets. One is application record, which is 54.34 MB, and also we have 4 lakh observations and also 18 variables, and other one which is a credit record which has 15.37 MB, and it has 3 columns, and common column is mostly client ID, which connects both the files, and application record consists of client's personal and bank information. And coming to the credit record, we have it consists of a client's credit card usage information most probably, and I'll be explaining the attributes in this project. Like we have ID, which refers to the applicant ID, and coming to the code gender, it says whether the applicant is a male or female, and flag own car, which means whether the person has or the applicant has a owns a car or not. And coming to reality, it comes to like it's whether he has a property or not. And count children, which is nothing but number of children, and amount income total, and income type, we have different kinds, whether it is coming from the working or pension or anything else. And coming to the education type, it's most probably the education level that they have, educational status. And coming to the family status, it's like marital status, whether they are married or single or divorced or anything. And coming to name, housing type, and it could be rental or own, anything. And coming to the days of birth, we have a different kind of attribute, which in this we probably see the values in negative values or something. This most probably is the day of birth, and this is and this column has the values that is with the negative values. That means from the current day to the past, to the day of birth, and that is recorded as a this is my first time seeing the different value. And coming to the days employed, it is also start date of employment. And coming to the mobile, it is like whether he has a phone or email, and all those attributes comes under that. And occupation type, we have a lot of people in different occupations, like they could be in any mode of occupation. And coming to the family members, we have how many members in the family, and monthly, and this month's balance and status, actually they are from the other file. I have merged it while processing the data. So month balance obviously has a month of the extracted date, and this status has a different values in its column, mostly like x, c, 0, 1, 2, 3, 4. And I have found the original like meaning of those. Like if this column has x to a particular applicant, it is like no loan for the month. And if it's c, it means the paid off that month. Or if it is 0, it means it has the applicant has 30 days past due, and so on. So coming to the data cleaning, we have I have found the null values and replaced the null values, so that for the first time I got occupation type as like the 13, like this much null values in this, and I have replaced it, and we got the correlation matrix, in which I can see for the first time when I did the correlation, I got uh, uh, one of the flag mobile, which is a column which doesn't have any correlation with the remaining factors. So I have removed it, I have dropped the column, and then I got this correlation matrix. And then mostly I've extracted the data after the initial data exploratory to draw the insights from the clean data. So after this, I have we got the target variable as this status, because here we can see the green value, which is a good applicants, and this blue is a bad applicants. And I can say that in this distribution graph, we can say like 2828 risky users who didn't pay, like didn't maintain a good credit record by paying their balance on the day-to-day basis. And next, I have like this is a count plot. We can see here like this is a income type distribution mostly. Like we have, this is an univariant graph. In this here we have income type. So most of the applicants are working in this through this graph. We can say most of the applicants are working, and there are less people as a student. And we have a code gender, like which is we can tell how many people. This is also a univariant graph, and this I can say count plot for gender. So we have most applicants as a females, and we have only these many people as males in the application. And coming to this graph, we have education type distribution, and this we can see this is also a count plot for and also a univariant graph. And this we can understand we have secondary. This is an education type. Most of the applicants are having education level as a secondary type. And also less applicants have academic degree. And we can see the status. And coming to the family status type, most of the applicants are married, and few people are widow, like that is the least number of application applicants. And coming to the housing type, we have most of the applicants have a house, their own house. And there are less people who are in the co-op apartment. And coming to this is a bivariant graph. In this we can tell the gender versus housing type, where we can see the this blue color as a male, and this like this color as female. Here we can see the most of the applicants have a house as apartment. In this most of them are female, and we can say male are like comparably they are less in the same thing. And coming to this, it's family status versus housing type. And this we can say that we have mostly in this we can say like for blue we have civil marriages, and we have differentiated through these colors. So in this graph I can say that most are the married people having the house, and most of the applicants. And okay, now coming to the feature engineering, I have converted the days of birth and days employed which are having a negative values that I have mentioned in the start. That is, the values are mostly from the current day. If its day of birth is today, it's mentioned as 0, and if it is the previous day, it is -1. So in the same way, when the date comes, it's I have converted the value into the date. And I have used different functions to convert this. I have calculated and replaced the values with age and number of employed days. So and I also have replaced the categorical values with numerical values. And coming to the data modeling, I have used different regression models and classification models, mostly logistic regression, XGBoost, and random forest, decision tree, KNN classification, and also SVC classifier, and also navy base. Here I got random forest as the highest accuracy, but at the first when I modeled this, I got a less accuracy. After hyper tuning, I got the random forest as the highest, like 94%. And here comes the logistic regression, where I have like uh, like where logistic regression model mostly predicts dependent data, which is like analyzing the relation between like one or more existing independent variables. Mostly here I got 0.57 as my accuracy, like 57%. So I've tried X3 boost, where I got 87% as accuracy. And also I have used SVC classification, where X3 boost is most probably a tree boosting, which is like a leading machine learning library for regression, or either it can be classification or ranking problems mostly. And coming to the K-neighbors classification, I got 0.82, I'm sorry, 0.69 as my um, accuracy. And coming to navy base, I got 0.69 as well. And in decision tree, I got 77%. Actually, coming to the hyper tuning, we know that like in machine learning, hyperparameter tuning is the problem of choosing a set of best hyperparameters for a learning algorithm. So hyperparameter, which is a whose values like use it to control the learning process, is nothing but a hyperparameter. That's what I have understood from this. And I have also learned this. But after doing hyperparameter, mostly I got random forest, the accuracy as a 0.94. And it's pretty much more. And coming to this, it's a feature importance, where I got the graph. In this, most probably I got days employed as a most affected feature, it has the most effect. And coming to this, it's an ROC curve. So for the random forest, I have done the most, like I have used grid search CV, and also I have seen the best estimator. And also after that I have tried ROC curve. In this randomized search CV, mostly I got it as ROC value as 0.97. Most probably it's a good one. That and Coming to the challenges I've faced in this project, understanding the data, that is where I mostly the days employed or days birth is most challenging column which I have learned in this project. And coming to the selection of risk factors, and also modeling, finding the best model to improve the accuracy of the prediction. And coming to the conclusion, we have random forest, which gives best accuracy, which is 94%. And also like logistic regression gives the lowest accuracy. And here we have uh, income type has the most affected. So Yep, pretty much. From this, I can see that for the future scope, we can improve the algorithms by cleansing the data more. Like we can improve the accuracy more. Uh, yes. Thank you for the